preparation for moving forward. And so I'm going to pass the test back today. I don't think I put them in yet because I wanted to talk about a few things. Like first things first, there was traditionally, I'm going to talk about some of these things as well, but like looking at the test traditionally, one of the easiest things for students is cussing the data in context. In that first free response question where I asked, or the question was to analyze the distribution. Over half of us did, but like one of the first things that we see when we see analyze the distribution should be thinking cuss the distribution, cuss it in context, center, unusual aspect, shape, spread. Too many of us didn't do that. And we need to be careful with context. A couple of us got thrown off by the context and so it affected things. The last question, when it asks you of that same problem, when it asks you, hey, is it better to have the rivers colder than, was it 8 degrees Fahrenheit or Celsius or something, versus warmer? And I need y'all to remember, this is something that we talked about in class multiple times. You have to directly compare the distributions using cuss. A lot of us talked about maybe just the skewness or maybe just the median or just whatever, but like compare the centers, compare the spread, compare the shape as well. So those are things that you got to remember, like compare them in context. So traditionally, I don't think I do a retest on this unit, but I want to talk through a couple of things. First things first, I need y'all to hear me clearly on this. And I was telling Serena and Peter this during first block because they're my TAs then. Legitimately, I think y'all might be, as a class, one of my favorite classes I've had because I'm not saying that we have all the strongest students, but like in terms of AP stats, like y'all are just good, like, and you're capable of amazing things. And like, I like the way that we interact in class and the way that we're working in class. But we're not succeeding to the level that you are all capable of. This is the first class, AP Stats class I've ever taught where I legitimately believe that everyone is capable of passing the AP exam. Like, in past years, there was always one or two where I'm like, this is going to get dicey, okay? It is capable in this class, where we all are earning college credit for the AP Stats. But we do have to fix some things. I see that for a lot of us, we're asking for more practice in class. And I get it, 100%. And I will try to build it in. But we have to remember that the AP exam is something that's coming up. And unfortunately not this semester, it is next semester. And so there's time constraints that I can be moving at. I'm going to try to slow down a little bit. But one of the things to remember is the progress checks, going over that, that's some of that practice. Going over the DYUs, like breaking those down and going over the issues there, that's practice. And I know someone said practice that's not for a grade. And there are all those homework assignments, and I know that we have a lot going on. Like some of us have multiple classes. I know AP Chem is a huge burden. Not burden, it's a great class. I loved AP Chem in high school, but like, it's a lot of work, right? And it's not the easiest work ever. It's not, okay? But, and then some of us are working a good bit, and working and doing cross country, right? So we have to figure out how to be efficient with our time. And we have to figure out how to master some of these ideas a little bit more quickly. One thing I would suggest, at least, and I'm going to talk about some more of these things. One of the things I would suggest is, it feels like for some of us, when we're doing the practice, if we're doing that homework practice, it's like right before an assessment. But like if you wait 3 lessons to do a homework assignment, practice assignment, then you have way too much to do in a single night or even really 2 nights. And 2, the whole idea of that practice, that homework assignment, is to give you a chance to solidify when we do the lesson. So if you wait 2 days, 3 days, a weekend, before you do that homework assignment, that's gonna make it hard to master those concepts. And I know that for some of us, we're working a lot. But a couple of things I want to put in perspective, and I know sometimes bosses are whatever about forcing us to work whenever, but you are going to have the entire rest of your life to make money and to work like that. Put the investment into your academics right now so that you can make better money in the future. 2, don't forget that you're a high school student. High school students aren't meant to be put through that kind of workload, like legitimately. It's not healthy for you to take on that kind of burden. So I just encourage you to like find a way to have conversations, if that's you, that you can maybe work a little bit less so that you can be focused. And I do want y'all to understand, we're doing okay, but I think you're capable of more than just okay, and I want that for you. I'm here every morning, I would say between 7:15, 7:20. You wanna come up here and ask questions? I'll work with you. First block's my planning, so I can put all of my time and effort into getting ready for the day or putting grades in, stuff like that during first block. Come on in. A lot of afternoons I can be here. If you don't have anything first block, I know some of us have TA, things like that. Take advantage of that time to come in. All that to say, like, I want you to be successful. I am gonna give your test back. I'm trying to think through if there's anything else I'm missing. Again, trying to slow things down, I get that. One of the things, again, I will say is this. One of the best times for me to slow down is the next day if you've done the practice assignment and you say, hey, Mr. Kenny, I didn't understand how to do this part of the practice assignment. That's a huge hint to me that I need to slow down. But if we haven't done the practice assignment, you don't know if I need to slow down, and I don't know if I need to slow down. So, working through those practice assignments there. I know I had at least one person say a huge review before a test. One thing I will say is that's kind of what the AP free response questions are supposed to be, is that review. It doesn't hit everything. The last thing I want to say is this. The same thing that I tell my Algebra 2 students all the time. I don't care when you learn it, I do care that you learn it. And so, we got to make sure that the first 2 units we get better at. Even with the retest, which I need to check to see, I don't think I put all the retests in for Unit 1. We only did marginally better. I will give him props. I think Star went from a 70 up to a 97. That is not the norm for people on that retest. The test I'm about to give back right now, I sent the email yesterday, I think, that I'm not giving your papers back, because what I want you to do this week, beyond by very date, is I want you to look through your test, and I want you to identify how to fix the questions that you got wrong. I gave you the correct answers when it came to the multiple choice. I need you to tell me why those correct answers are the correct answers. I need you to look through it to understand, to improve your understanding. I need you to resubmit that, I want to say by Thursday, so that I can give you feedback on Friday. Okay? Or return it to you with feedback on Friday. That way you have some materials to study for a retest, because I don't care what you scored, everybody could do better. Some of us did phenomenally on the free response, but they maybe struggled on multiple choice. Some of us struggled in general, some of us did really well, but like, we can all do better, and I want you to do better. There were some that y'all missed that we cannot miss. And so I'm gonna pour over this and see what else I can do to help support y'all. Please understand though, and I do want y'all to hear me clearly on this, I'm here to help you. 100% here to help you. I need you to communicate with me when we're struggling with a specific topic, with whatever. Otherwise, I can't help you. If I don't know, I cannot help you. 2, again, make sure you're also being intentional about the time that you do have, so that you can master this to the best of your ability. Okay? Can I get about half of those and you take the other half? Go ahead and get your bivariate data stuff out. The two variable things. We're going to recap some important ideas with squared up. And then we will continue working. Okay? So Kinsey's the one that's messing, right, Madeline? Oh, yeah, that thing. So I need to look to see the progress check, but I figured with the conversation that we had, that we needed to have today to start today, thank you, Katie, I think it might be better if we do the DYU tomorrow to let y'all decompress, study a little bit more. I don't normally want to do that. Doing it this way may push 2 DYUs back to back, but hopefully this will give us a little bit better time to prepare. I know when I checked earlier, I think 6 of us hadn't turned in the progress check yet, and we've got to start doing those progress checks. So that we may do progress checks tomorrow, Dixie. Okay. So, make sure we're being efficient. And again, I will also say this, one thing I do want to point out, when I say being efficient with your time, you do have to have decompressed time. Like, I know that a little bit of time every single day after Alex goes to bed, I play 10-15 minutes of Balatro because it's fun. I get to shut my brain off. If you've never played Balatro, okay, it's such a good game. It's a
it's the roguelike where you need to generate a poker hand and you're collecting the jokers to increase your rolls for your.
It's very loosely based on poker, but it's free.
And it's not game.
And it's not game. Just to clarify, it's $10 for the game, but then you're not gambling in it. At least I had to pay $10 for the game. It's so good though. That my wife and I, at least right now, are watching.
It was actually Game of the Year.
Big Brother. It was. Big Brother is one of our go-to reality TV shows. Anyways, least squares regression line. That's where we ended. We're going to talk about residuals to recap. Yeah. And also, by the way, I do want to point this out. I should have said this earlier. With your test, my priority is you learning. Okay? That being said, you're going to get a chance at a retest. If you need to talk to other people to learn, I'm okay with that. Copying their answers doesn't make any sense. But asking people questions and getting help from your friends, fantastic. Do it. If you need to come in before school and ask me for help, or come in after school and ask me for help, fantastic. So I'm not expecting you to do the test corrections completely on your own. I'm asking you to at least first attempt them on your own, but then ask questions of others. Okay? My priority is your growth and learning because you're capable of amazing things. And just like, have I told y'all what Alex tells us every time we ask him if it's okay if things are hard? Have I told y'all this story?
I don't know.
No.
Yes.
Huh? No. It gets better. I guess I should say, I do tell him to say yes, but then I follow it up with, what do hard things make us? Stronger, bigger and stronger, right? So someone at the door? Yes, go. Go! Okay, so hard things make us bigger and stronger. Okay, so we're going to recap the squared up task. Oh yeah, Phoebe, you have to go as well. Yeah. Squared up task for least squares regression line and residuals. I need to make sure we are clear about some things because I think one of the things that hurt us on the test was not labeling some things. And we need to be intentional about the way that we label so that we think through what stuff is. Like if we have a z-score, we need to know that that's the number of standard deviations above or below the mean. That's not a percent, that's not an area, that's not whatever. You got to be clear with your labels. So right now, we are still identifying the slope and y-intercept of a line in slope-intercept form. And we are building on calculating the least squares regression equation, which there was a formula, right, for, I guess the line, not how to calculate the least squares regression line. What are we going to use to calculate a least squares regression line every time, though? I can tell you this, I ain't doing it by hand.
The calculator.
Yeah, I'm going to use that calculator. Or they're going to give it to you in that mini-tab output form. Extrapolate and interpolate. What does it mean to extrapolate data?
It means to make a prediction outside of.
So extra means outside of, right? Make predictions outside of the data that we have. Interpolate, what does that mean?
It means you're making a prediction within the scope.
So prediction, again, guesses, within the data set, right? And what are we using to extrapolate and to interpolate? Huh? Which formula, which equation? The,
Y is equal to A plus BX.
be careful, one, be very, very careful about this.
Y predicted
Y hat predicted, but what do we call this thing again?
So, least square regression.
Least squares regression line, right? We can have just a regression line in general, but we want the least squares. Remember how we talked about reducing that sum of squares as much as possible, right? So a least squares regression line there. But we have to be careful with which of those, extrapolating or interpolating?
Extrapolate.
Extrapolating. Remember, we went to year 0, and Charlie looked at me like I was crazy because you're like, Mr. Kenny, negative 454 years? That's dumb. And I agree with you, but what was the issue? We were extrapolating way too much. You can't go too far outside your data set. That's what you need to be careful about. And then we got to talk about residuals. What is a residual?
It's the difference between the value predicted and
So-
the actual value.
It's how far, right, a value is from what is predicted. We're going to look at these in a second, but I do want to recap those things. Did that completely take out? I didn't mean to. Oh, I put it right here. Okay, so I'll go back to the Barbie doll stuff in a second. I know that's really small, but that's the email I sent to y'all this weekend. I do want to remind you that, again, the calculator will spit all this stuff out for you. You had to do this to get the sum of squares. You had to do that, I believe, in the data and statistics page. But to get this regression line equation, the least squares regression line equation, you can do that in list and spreadsheets or the equation. All right. So right here, remember, here's examples of interpreting. I'm not going to spend a ton of time here because if you haven't done it, I want you to try to do it. And if you have done it, hopefully you've already checked yourself. But please notice, the biggest thing I want you to see here is every single time I labeled stuff. If you label things, it's way harder to make a mistake. And there's lots of variables going on here, right? Last unit, we introduced a lot of things, but now we got lots of variables. But if I label it this way, hey, every one what? Year, and changes in year. So every extra year, I think, was this the women? So there's the predicted lifespan of women is what?
28%.
It's increasing. Remember, these are years. The fact that it's positive tells us it is increasing. Remember, we're not talking about percents. We're talking about variables now, right? It increases by 0.28 years. So for every 1 year increase, the predicted women's lifespan typically increases by 0.28 years. I put that typically in there because it's an average idea. And then don't forget with the y-intercept, gotta start with the 0, but year what? 0 AD, which I think you brought it up, Charlie, last time, and I knew this once and I forgot it. There is technically no 0 AD, right? It goes from 1 BC to 1 AD, which is why we have CE for Common Era. Is that what it's called? Okay. So, there we go, right? But in the year 0, can people live negative 479 years? Totally impossible, right? That's the danger of what? Extrapolating. So you gotta practice these things. Now, one thing, and I didn't do it here, but I want to point this out. If you look at number 2 versus number 4, which one is more clear what we're talking about?
Number 4.
Number 4, right. I've got the variable in there. When you put the variable in there, it makes things more clear, right? Predicted Y. Well, predicted what? Oh, life expectancy for women. I gotta look there. But right here, predicted woman life span. It's very clearly laid out. 1965, right, is my input there. And then your inputs here. So the other thing is, and I guess I didn't write it, but I did here. Notice I have year here, year here. That makes it more clear what I'm going to substitute in, right? I know that I need to substitute year in there. If you write out the equation with the variables there, it makes your life easier. Now, what I want to focus on, so I'm skipping all that, check your answers on your own time. What I want to focus on really quickly is a residual. I need us to understand what a residual is. And if you can tie a residual to a graph to make it make sense, it'll help a lot. So first off, how do we calculate a residual? Like, what is this number and what is this number?
A residual is the actual value minus the predicted value.
One thing I remember I showed y'all AP, right? You're in an advanced placement class. The actual Y value minus the predicted Y value. Which the actual Y is already given, 70.1. If you go and look at the table, or if you look at the graph on the calculator, in 1980, the average lifespan was 70.1 years for men. But then to get the predicted, it's not that simple. Predicted always comes from the regression. I want to make sure that's clear, that we understand that clearly. Predicted comes from least squares regression line, okay? And I just substituted that 1980 in. And then I subtract those two. And if you visualize this right here, this number is going to make way more sense. I'm not going to draw the whole thing, but like what we want to recognize is at 70 years, right, my actual value is, say here. Is that prediction above or below? Below, right? So like if you think about it that way, it's that distance from the actual value down to the predicted. So we need to understand how to interpret this. The interpretation of our z-scores and a few other things kind of got us on the last test. We've got to be careful about this. And the percentiles. We've got to be careful about those things. This 0.31, what is that saying? Like I've just done the calculations.
There is a difference of 0.31 between the actual volume and the predicted volume.
You're very close. Say again. The way that you said this, Raina, it could be either of these, but it's only one of them.
Possible.
Huh?
The actual value was above.
Okay, so the actual, you say value, what's the context? We got it, actual, well remember this is actual right now. Actual men's life expectancy or lifespan was
0.31 above the predicted value at x equals.
above predicted at x equals or in 1980. Again, I want to point this out. If you look at, picture a drawing or sketch it really quickly, and you see that 70.1 and you see that predicted, that's exactly what this is saying. The actual men's lifespan, the actual Y value, was 0.31 years above what was predicted. There's predicted being below it. Specifically in that year 1980. It's not for every year, it's only for the year 1980. And we've got to interpret it that way. Yes?
Our number 3 is a different year too.
Wait,
It
wouldn't it be
says
2.1?
Oh, did I change things at some point? Then I must have.
Oh, no.
Oh, I I grabbed the wrong one. Thank you for pointing this out. I'll have to update my answer key. I forgot that I changed this. I must have changed it after I did a solution key last time because I forgot to go back and look. I had solutions and I just put it in there. That's totally my bad. This is a way better set of questions. I was wondering. It's a way better set of questions because it's actually got correlation coefficients stuff like that. My bad, guys. I will send you answer key tonight, maybe after lunch, because I might be working on that during lunch because I'm embarrassed. Thank you for having that, catching me on that. Okay, but at least hopefully that helps with residuals still. So drawing a picture, making sense out of it. Now you get to do the check on your own, right? And then check your answer. Okay.
Oh, we have one more question.
Go for it.
What is her decimal I'm supposed to follow? Because I put like 6 decimals
Yeah.
after.
I would say, let's say it this way. If it's an area, so talking about that normal curve, right? Area, 4 decimals, okay? If it's anything else, I think 2 decimals is enough. Ooh, let's actually say area, let's say probability or area. Because the area ends up becoming a probability. Typically probabilities, they want 4 decimal places. I believe everything else 2 decimals is more than enough. What I will say is this, 1 decimal is not enough, 0 decimals is not enough, so at least 2 is a safe bet. You get into the probability and area stuff with normal distributions, other things, you want 4, is generally what is accepted. What I will also note is, if I'm doing calculations though, in my calculator, I'm gonna keep all the decimals in there and then round at the end. I think that's what you did in calculus as well, right? Like you kept all the decimals and rounded at the end.
Yeah.
I asked that because it's been way too long since I've done calculus. Alright, let's go back really quickly. I do want y'all to remember, this is that mini tab output from a calculator. How am I supposed to get my equation out of this kind of thing?
You have your coefficient.
You have your coefficients, right? This is the coefficient of the constant. What is that going to end up being? Notice they have r squared down here.
So why does the constant
It's gonna be your R.
And y hat equals a plus bx.
This is gonna be your A.
So remember, this is the coefficient of a constant. So that is my
B.
constant.
I was right.
No, you said no, my guy.
No, I said A first.
Okay. Notice, that's the coefficient of a constant, which is a weird way to say it, but that just means it is the constant. This is the coefficient of rubber bands, which means rubber bands must be a variable.
So it's B.
So that's my B. 464 times rubber bands. And so what are we predicting again? Distance traveled. So the predicted distance is equal to that. The mini tab output does show up on most tests, so we need to be aware of it. We haven't talked about it heavily. I gotta figure out when I'm gonna build it in. Does anyone remember what this S right here is? You're right. Standard deviation of what?
Of
Something else I've already talked about today.
The
The residuals. So it ties into those squares, right? But it's the standard deviation. The S is the standard deviation of our residuals, okay? That was like the last little thing I talked about at the end of class. I think, if I remember the formula correctly, and it's actually on the back of your formula sheet, and you'll never do this by hand, but we take our y value, and what is kind of the mean with 2 variable data? What is like a mean that we see with 2 variable data?
this is not the Y one.
What is like the mean for the 2 variable data?
Squared.
So we're gonna look at the residuals, but remember I'm asking like what is the mean? It's like if I look at the 2 variables, what? Let me ask a different way. What is a mean?
The average between among
You're telling me how to calculate it. I asked what is a mean?
The average.
Average.
distance between
Average.
It's a measure of center. Remember, when we talked about the candy grab activity, when we grabbed our starburst, right? I asked you, if someone else were to come and grab starburst, how many would you expect them to grab? 20 or so, right? Which was the mean. That means the mean is an expected value. When we say a measure of center, the mean is an expected value. So what is like a mean for 2 variable data?
the expected value.
What is that?
The predicted value.
What is that?
Sum of volume minus mean squared.
Say again.
sum of mean minus, meaning the volume minus mean square?
Oh, x plus the actual.
Hold on, let me rephrase this again. So, this is the average lifespan of a person right here. You good with that? Okay? Here's the mean. Right? See how the mean is in the middle of the data? Right? And that's what I would expect to see if I was to get another year in here, right? Okay? Let's go back to our 2 variable data. If I were to look at this set of data, what is kind of like the middle of the data that is helping me predict values?
1950.
The what? The line, guys. Isn't this line a whole lot like that mean that we saw right here? This line is going through the middle of it? Okay, so when I ask what is like the mean for 2 variable data, I'm talking about
The least square regression line.
the least squares regression line. That's the mean. Okay, so I think residual, or someone was saying the predicted value, and I'm like, yeah, the predicted value. What is the predicted value?
The least square.
The least squares regression line, the line of best fit, right? Like that's what I predict to see happen. Okay? Now, 2 things I want to point out and remind you of here is this. So there's that mean, right? And that's for the 1 variable of a person's lifespan. Right here, I was showing this to someone during before school. This is craziness what's going on here. But this line right here, that is the mean of my y values. See the mean of the y values right there? It's just like the previous page, but it's horizontal because the person's lifespan is this way. What's the sum of squares here?
1393.
Okay, that's a whole lot of variability. And when we say sum of squares, what that is doing is that is taking a value, subtracting the mean from it, and squaring it. Remember, that's that is the foundation for standard deviation. If I was to do standard deviation, divide by n minus 1, to find the average of those squares, and then take a square root to undo the square. Okay? We good with these average, or that being the sum of squares? Or I totally forgot the actual sum. We sum all those squares together. I've created these squares in here, summing them all together. We go with that. Okay? But if I click on this trend line here, that is the sum of the value minus the predicted squared, right? And I have made those squares as small as possible. And so this sum, what was it? Was it 1315?
1393.
1393? Oh, 0.15 is what I was thinking of. And this sum of squares is what?
41.0963.
Man, did that trend line do a really good job of minimizing those squares? Of making predictions there?
Yes.
Like, it's pretty darn close to it's reduced that sum of squares a ton. So, what percent did it reduce it by? How would I find it?
You divide predictive versus how do you call the bigger number?
So it's the total sum of squares. Total sum of squares, and this is the sum of squares from the residuals. And then if I do 1 minus that, what do I get?
You get a point.
0.97 something, I
Yeah,
think.
0.97.
Oh, yeah.
0.97.
Or yeah.
0.9,
971.
971. Okay, so I want to pause though, and I do want to point this out. We need to be careful in stats. That's what we calculated, but what did I just get? What is that thing?
Is that not the
R.
The correspond-
That's my coefficient of determination, the r squared. But here's what I want to point out, and I need us to be careful about this in a stats class. We need to remember that in a stats class, there's how to calculate it, but then there's also how to interpret it. And in the real world, you know what's way more important? Interpreting it. Guys, the calculation, I have calculators to do that. But when we are looking at it, we need to say, what does this thing mean? Okay, what is it? And we need to recognize, hey, that's the amount, the percent for the sum of squares that was reduced by this least squares regression line. So 97% of our variability was explained, variability in the person's lifespan was explained by a linear relationship with the year. Okay, so those are things to keep in mind. So hopefully that was a good little recap from last week. I know that was a long amount of time and the bell's about to catch us. So we're going to pick up, oh, and then here, don't forget to make sure you get these quick notes that I emailed to you. Yes, Charlie, I do email. Please check your email. But these quick notes that I emailed to you also that you can interpret. We've got to be able to interpret. Yes, Charlie?
For number one, what is that thing beside the y equals a?
Y hat, and then I labeled A as Y intercept, B as slope. The thing to the right here? Oh, so right here it says making predictions, like how to make predictions. So you substitute the explanatory value in to predict the response value. Okay. When we get back, we will start with the next lesson.
How'd you do on that?
Yes.
Yes,
you can do that.
Bless you.
If y'all could quickly look at your proficiency scales and do a reval, think, is there anything on this foundation that I need to re-explain or recap or all that stuff? Okay, so look at that foundation. The foundation will be on the back side, Ian. Yes, ma'am.
Plot is the plot that where you're calculating the residual.
Back side. We have not talked about a residual plot. The foundation. All of these things we should hopefully know.
Wait, can you give me an example of an input and output?
Are you serious?
Like oh! Right.
Input,
Yeah, okay.
and whatever it equals is your...
Yeah, that makes sense.
So all the predictions that we did, we substituted input in, got an output out. Okay. Alright. Anything else? Regression line. So remember, a regression line is a trend line. Remember how with square it up, you put your own line through the data points? And that would be a regression line or a trend line. But the best regression line is the least squares regression line. So you can do a different trend line, but in the AP world, we want the least squares regression line. So a regression line, or a regression curve even, just is a model that predicts your data.
So can we call it a regression line if we're the one?
If you create it, it's still a regression line. It's not a least squares regression line unless you make sure that it is the least sum of squares. Okay. And there's ways to do it by hand. It sucks. Don't do it. Don't ever. All right. Any others here? Okay. Target. So here's our target. We should have the top section of this. For the most part, we should be able to, and please notice it's not just report R, interpret the correlation R, the coefficient of determination. We need to be able to describe or analyze the distribution of bivariate data. Remember, with univariate quantitative data, what was the acronym we used? CUS, right? For univariate, we CUS our context or our distribution in context. When it's bivariate, we need what? DUS. What does that D stand for? Direction, unusual aspects, form,
Strength.
and strength, right? So remember, those are the four things. And again, do you need context?
Yes.
Yes. Okay. So we're going to continue working on the DUFs today. Calculating least squares regression equations. Again, calculators use that, but we need to be able to use a least squares regression line to extrapolate and interpolate. We need to be able to interpret residuals, y-intercepts, and slopes. So you got practice with that. I'll try to do maybe a little bit with that tomorrow or hopefully you do some of that tonight to know before the DYU tomorrow if you need to ask questions. Okay? I think that's all I got. Right now, the lesson we're about to do, it's all about residuals, but using those residuals to help us work within a residual plot. Any guesses what we're going to do with a residual plot? Plot what?
Transfer it,
Use it to make
transfer it.
Plot residuals.
If it's a residual plot, we might be plotting
least square regression.
residuals! You already have a least squares regression line for the bivariate data, right?
I didn't hear the question. I'm such a cross.
Okay, so if it's a residual plot, yes, we're going to be plotting the residual, but there's a lot of important stuff here. So this is lesson 4, okay? This lesson will not be on the DYU, maybe a question or two, but it is not what I planned for the DYU. I might update things based on where we get today, though. Okay, so should you buy stock in Monster Energy? So this is Monster Energy from 2006 to 2022. I'll tell you this, if you're my brother, then yes, you want to, because White Monster is apparently life. Alright, so at this point, you should be able to complete most of these questions together. I'm going to help support you, Mr. Anderson will help support you, but let's work at vertical surfaces, help you get up and moving a little bit. Write your responses on a vertical surface near you. What? Yeah, that's it. Yep, 3.4. You're good. I'll draw on that residual plot in a second. Okay, so really quickly, I will point out, I should have asked this or pointed this out earlier. Number one, I am glad that y'all went ahead and did DUFs, like you went ahead and hit direction, unusual aspects, shape, form, or form, shape, but it does just specifically ask for what, number one?
Describe form.
Form.
Oh,
Just trying to, yeah. Second, I do want to point this out, okay? Around the room, everyone said linear except the Jacks.
Hey, you didn't say we were right.
Yeah.
Because we're right.
It doesn't look linear because there's some things that are close to the path of
Linear is the same.
It's exponential.
Oh my.
I don't know about exponential, but I do want to point out, does that curve approximate those points better than that line does?
Yeah, sure.
Okay, so is that actually a linear relationship?
No.
We're going to learn how to handle nonlinear relationships soon, but I do want y'all to be careful because I know the temptation is to just always say, hey, it's linear. I get that. I was tempted, okay? But actually look at the relationship. There's a free response question that got me, and it was literally just one data point. I was like, man, if I just ignore that data point, and then I got a P on that free response question, or that section, because I called it linear and not nonlinear. Right? If it's nonlinear, let it be nonlinear. That's what we have here. We're going to talk more about this in a second. So positive and nonlinear. I'm good with that. So right here, the predicted stock price for 2010 is $7.53.8, and the actual is whatever below that. Now, I do want to point this out, and I need y'all to quit doing this. Don't do all the work in your calculator. You need to write that crap down. If you do the work in your calculator and you don't write it down, you at most are getting a P on the AP exam. They need to see where those numbers are coming from. So like when we say the predicted stock price is equal to negative 5,608 plus 2.7938 times 2010. Notice all I did was I substituted that value in. Take the time to do that. Then my predicted stock price is $7.538. Okay? Then it asks for a residual, right? How do we calculate a residual?
You need to plug in the year for X.
We already plugged in the year for X. We got the predicted. I want the residual.
The actual
It's the actual minus the predicted. So what was the actual?
For which number?
2010 was $3.68 minus the 7.538. And so what is the residual here?
Negative.
Okay. So again, when we talk about residuals, and I was talking about this with Charlie, I will say here on this question, it does just ask you to calculate the residual, but on the AP exam, if they ask you to calculate a residual, just go ahead and assume they want an interpretation.
Gotcha.
Okay? Sometimes they'll say don't. Like I will point this out on y'all's test. I know at least one person took the time to calculate outlier on one of the free response questions and then drew it with an outlier shown. But the question specifically said don't worry about outliers, right? So like take advantage of that when they tell you those things. Now, so it doesn't actually ask for this interpretation, but we do want to remember what this means. Like if we look at 2010, and again, this is what I'm talking about with visualizing it, the actual stock price, average stock price, is above or below? Below. Is $3.858 below the predicted in 2010. Notice it's not for any year, it's in what year? 2010. We've got to have that context in there, okay?
Mr.
Yes, ma'am.
So are you, in number 2 and 3, are you saying we have to show the work of how we calculate it and interpret the residual?
For this question, right, for the assignment, just show the work for the calculation. On the AP exam, interpret. We got to remember these numbers mean something. Now, if it just asks for calculate or determine, then you can get away without interpreting, but I can tell you this, 9 times out of 10 they're going to ask you to interpret as well, so just prepare for that. Okay, so numbers 2 and 3, I think everyone got the same answers from that point. We need to start looking at the rest of these. Can you hand me the, nope, the other one, that one, yep, the remote. So, please make sure you show your work for numbers 2 and 3. Number 4, do I not have the, oh, no I don't.
It's frozen.
It's, well, it's that too, but this is not the slides. All right, so numbers 4 and 5 and whatever. Can I erase this? Is that okay?
I like it, that's a lot of hard work, I don't care.
I mean, I'm just looking at, there's a lot going on here. Okay, so I'll just leave it. So notice we are literally just filling out the predictions and the residuals that we just did right here. So we already have that, that's good to go. Number 5 asks us to quite literally plot the residuals, right?
Right.
And so rather than didn't y'all have a plot over there?
We just put it on paper.
Did you erase it?
What?
Or was it just on the paper?
It's just on the paper.
Oh, why did oh, it was on the paper. Yeah, you're right. Okay, does anyone have a plot?
We have one dot.
They have. Okay, so we have one here. Okay, it's hard to see. I'm gonna make it a little bit darker for some of these. And so when we look at this, I know I talked about a different group. Is there a pattern?
Yes.
Yeah, if I draw an approximation, there's a curve in there, isn't there?
Parabolic
Okay.
almost.
Parabolic almost, quadratic, okay? So, notice all we did though is we graphed the residuals, right? When you graph a residual plot, that's all you're gonna do. I will point out right here, okay, is our 0. If we have a point on that 0, what does that mean?
It's the same.
The value was the same as the predicted, right? That's exactly what that means, right? Because earlier, Ethan, you were kind of looking at the table, right? Trying to figure out where there was more or less, but I can see it right here. In these years, the actual was what in respect to the predicted? It was more than the predicted, right? Actual minus predicted. Whereas in these years, the actual was less than the predicted. That's the beauty of a residual plot, okay? First and foremost. But the biggest thing is number 7. Okay, so we should have our answers across, again, using the residual plot. Does the residual plot have a pattern?
Yes.
The answer is yes. What does a pattern in the residual plot, you think, suggest about the linear model?
That they have they're correlated.
Oh, it's both that seem to have a curve.
Notice that residual plot is curved. That residual plot has a pattern. So was a linear model a good model?
Maybe not.
Notice how this, like, and this is something they don't really talk about often, but it helped me make sense out of this. take this line in your mind and rotate it so it fits here. That's all this residual plot is these data points on this line rotated horizontally so that we can clearly see that curve around the line. Remember how we said this is where the value is the same as the predicted? So that 0 right there is your trend line. The fact that there's a pattern means that a line was not a good prediction. Okay? So I want us to notice right here, if there is a pattern in the residual plot, a line is not a good model, prediction, etc. So these are models, right? Bivariate data, we've got models. If there is a pattern in the residual plot, a line is not a good model.
Well, pattern might be just a line.
Yeah, I mean, the pattern can be a line. So let me show you what we do want it to look like.
What if it just is equal amount?
Scattered. If the residual plot, residual plot needs to be scattered. We do not want a pattern in there, because it's not just like half of it's above, half of it's below. It's that it's scattered around there, meaning that it's not a consistent pattern above or below. Star, you good?
No,
You just made the ugliest face I've ever seen.
Okay. But let's get our notes down for number 7, so we can move forward, please. At least, actually, I would say all this stuff through 7. Get your residual plot down. The notes here for number 7. And get that information, please.
So, do we want it to be scattered?
Well, yeah, answer those questions. So, the residual plot we want to be scattered. Remember, the residual plot being scattered means that the linear model was a good model. If there's a pattern in that linear model, it's not a good model.
So if there is a pattern in the residual plot, would it correspond to a form of a graph?
If there's a pattern in the residual plot, it is a non-linear model. Or it's a non-linear relation.
What I'm asking is, so, of course, we can establish that, but if there is a form like a curve like this, would it be similar to the original graph that is
Kind of. I will say this, like, that's quadratic. That data over there is more than likely exponential. Just glancing at it. It may be quadratic. So I wouldn't necessarily think along those lines, just think linear, non-linear. If there's a pattern, we're saying non-linear is the big thing.
Mr. King,
See you soon.
quick question, like how do we find like the residual for 2010? Oh wait,
You did that, dog. That was number 2. The way you calculate residual is the same as it always has been, right? You get your predicted value, do your actual minus your predicted.
yes. Yeah.
So I do want to quickly show, I'm going to cover this up for just a second. I do want to show this. This is the square root task. You remember the other day when I was kind of like, linear is not necessarily the best? See why?
Yes.
That residual plot very clearly has a pattern in it. I will point out, was our R really, really high in this one?
It was.
It was like a 0.98. I think R squared was a 0.97.
Yes, right.
Remember that? So just because you have a high R, does that mean that it's linear?
No.
No, right? Does the linear model predict things pretty well? Yes, but there's probably a better model out there.
Yes.
So and that's why it's important that we not just look at R, not just look at R squared. You need to look at residual plots to assess linearity.
The first glance, I thought it was just strong. How do you determine the difference of moderately strong and.
You need to actually calculate R. Like I would actually calculate R. Yeah. But again, is it linear in the first place?
Not really.
So it's not a good question for that one, is it? But you need to calculate R if you want to determine strength.
This might be a question, and I just want to refresh on, but like, will they ever give like something like this without that formula and you have to find the formula?
Yes, but they gave you the data points, didn't they? So I would put the data points in list and spreadsheets and use list and spreadsheets to calculate the least squares regression lines. Right? Like that's what I was saying earlier, is I would never calculate it by hand, but I would put that into a list and spreadsheets and then use that to calculate it for you. So you would just do, when you go to stat calculations, you would do linear regression instead of one variable.
Okay.
Yeah, does that make sense? Because we did that, I think, with the candy graph, didn't we?
Yeah.
Yeah, so that's it, like you would just have to create your own model using a calculator.
Well, yeah.
Don't do it by hand. Okay. Alright, so I will say this, I'm gonna add it on here again, but this is where I was actually supposed to talk about what a least squares regression line was, but I thought squared up was better. So what is a least squares regression line?
The mean.
So it is a, ooh, hold on to that, don't let me forget to say that, Casey. So it's a regression line that minimizes what?
It minimizes
The square.
the squares.
Sum of squares. Don't forget, where's that sum of squares coming from?
The
From the residuals, right? So remember, specifically, it is the residual sum of squares. Okay? It is the residual sum of squares. So that's what the least squares regression line is. Yes, I love thinking about it as the average for bivariate data.
Bless you. What was funny? I don't think the president should act that weird.
Okay. Y'all still right that.
Get away from me.
I'm not listening to my It's not about this somehow.
Y'all dying over there?
They're okay.
What is going on with the poison my drink?
Good, you drank it too much. I'm sorry, Emerson, I don't know what you got.
Okay. So, you didn't have to draw these yet, but I will point this out, or this is a question I want to ask. I have 4 residual plots here. Please notice the statement I said is I have 4 residual plots on the board. Which of these residual plots would indicate that a linear model is good, and which of these would indicate a linear model is bad?
The good one
Let's say,
is-
I should, let me label these. 1, 2, 3, 4.
1 4 good, 2 3 bad.
How bad?
Let's do this. Raise your hand if you think 1 is a good model.
Wait, one up before? Or
Just number 1. Is number 1 a good model, or is number 1 a residual plot for a good linear model? So I've got 1, 2, 3, 4, 5, 6, 7, 8. Children. Okay. All right. Raise your hand if you think number 2 is showing a good residual plot for, or a residual plot for a good linear model. So we got 1. Number 3, would this be a scatter plot for a good linear model? You think so? Got 3? Okay. Number 4.
Wait.
Got 5. Okay, we can call it there. Now, remember, what has to be true for a residual plot to indicate a good linear model? No pattern, right? So nobody said 2, because we have a nice curve in here. Is it perfect? No. But, okay, so this would be a bad residual plot.
No.
Okay, right here, I know 3 of us were tempted, but this, remember, is a residual plot, right? Is there a pattern in that residual plot?
Yes.
Yeah, well, yeah.
So is that a good residual plot?
Yes.
That's a bad residual plot. There's a pattern there. Okay, say again. What about 4?
I see a pattern.
Looks to me like there's a pattern there. I know that one's very tempting. I know the first time I ever saw number 4, one like that, which I've never seen an actual residual plot like that, but it's always used as a model within teaching AP stats. You're thinking like, oh, it is scattered, and it is scattered, but as we move away from here, it's spreading out in a pattern. Okay? So if there's any kind of discernible pattern, linear is not a good model. This is the only good one.
If it is clustered around on one specific spot, is it call that a pattern? Like clustered around one clock?
Well, I mean, this is, in a way, it depends on your frame of reference, but it's clustered here. Are you talking about like multiple clusters?
Yeah, like really close.
We'll explore some more. Hold on to that question. But if there is a discernible, I think that's how you spell discernible, maybe ABLE, pattern.
Hey,
Is it A?
yes, sir.
How would you know?
Because I'm speaking. Because I know.
What do you-
I know.
If there's a discernible pattern in the, please notice, in the residual plot, a linear model is no good. Needs to be scattered. Okay. We only have about 3 minutes. So with the time that we have left, please start on the check your understanding. I'll let you know when we have a minute left, like 2.5 minutes. I'll let you know when we have like 30 seconds left, so you can start packing. This time you can ask questions as well. Yes? The what?
After the what?
Discernible. N-A-B-L-E. Discernible pattern. Yeah.
I was there, I used to. No, you were not there.
That's how it's only
I was just making sure, don't forget, I'm trying to make sure.
Hey,
Guys, do not forget, please be working on your test corrections. Any question you missed points on, show how to correct it, make sure you're thinking through those things. Raina did bring up, would showing why your answer is wrong or other answers are wrong be good? And the answer is 100%. Like the time that you take, and Emerson, you've heard me talk about this, like that process of elimination, right? Anytime you are able to eliminate an answer, it gets you closer and closer to the correct answer. Dive deep into those details. If I were you, I'm not going to require it, but if I were you, I would try to figure out why every answer choice is wrong and why, so that you can use that in the future. Please come by if you have questions about those test corrections. and I will be here to help you. Yes, ma'am. I would start there and let's try to, yeah, let's start there.
That's it.
Yeah.
Wait till that email checking. He's going to
No,
that.
Unit 2A, I haven't signed it yet.
Oh, you,
I know the Unit 1 meeting,
I'll sit in the staff.
but not yet.
There was like a unit
Okay.
You trust me, I have worse of you.
it was like.
I haven't assigned it though yet, have
It was
I?
like 3.
Hey, Mr. Kim, okay.
I reassigned some,
Why am I
unit
JFK? Because you're gonna get assassinated.
It was like 3.
What are you,
Who is this on?
That was the unit.
Barack Obama?
Oh, that was Unit 2, as the univariate response to prepare for your test. I sent an email about that.
I didn't do well on it.
Yeah, we gotta practice for your response more.
Honestly, I think ran out of time. I started to try to fill out the questions as fast as I could, so I could.
Yeah.
Is it off?